Alright, so back from break. Let's get our solution. We started calculating our first derivative of our function. We know we'll need that because we need our second derivative to plug in for y double prime. So let's take our second derivative.
The 1/9 goes away.
Alright, experts.
1/9 goes away.
1/9. There's no t involved there, so it's 0.
The derivative of the cos is negative sign.
So
What is the
9.
Negative 9.
Cos sine 3t.
wonderful. Yeah, wonderful. Awesome. Do we have all the information to be able to see if this is a solution?
We plug that in for
Yes.
y double prime.
What's that?
I said we plug it in for y double prime.
You're exactly right. So let's do that. So negative 9 sine of 3t plus 9 times our original function, which is 1/9 t plus sine 3t equals. Let's find out. Alright, so let's distribute 9 through here. 9 times 1/9 t is
Just t.
Just t. 9 times sine of 3t is 9 sine of 3t, right?
Yes.
Alright, so this equation becomes negative 9 sine of 3t plus t plus 9 sine of 3t.
And the 9 sine 3t's cancel out. And you're left with just t.
You're left with just t. We'll put it back up there for clarity. There you go. This matches up. So therefore, f of t equals 1/9 t plus the sine of 3t is a solution. See, not hard. Not that hard. You're just matching up the function and its derivatives.
But if it doesn't match,
Then it's not a solution. Not a solution if it doesn't match. So in other words, you can't solve this equation, this differential equation, with this function. So that function is not a solution to that differential equation. That's a good question, but pretty simple. Pretty simple. All right, let's look at our review stuff now a little bit. Did anybody have a chance to look at those problems yet? And maybe, since we're running short on time, want me to explain or do a specific one on it?
Is there any way you can like do the solution, like post it on there or something if we don't get time to do it now? Is that allowed?
What's that?
Like if we don't get time to do like these, can you like post the answers?
Well, I took a picture and posted this on Edmodo, and the solutions are on here.
Oh, they're on there.
And I don't know if you can read them clearly on there. I think if you look at them, you can probably. But I recommended that try them before you look at the solution, because if you look at the solution and think you can do it, that's a double-edged sword sometimes. Yes, you have the answer, and when you're thrown in that situation where you don't have it, you actually know what you did.
No, I was just saying if we didn't do it.
So, anyone in particular? The second one?
Yeah, I remember looking at that
Go
one.
for the second one? Alright, so number 2. I'm just going to abbreviate here. Angular velocity of u. What is your angular velocity on the surface of the Earth? I think I'm paraphrasing here. There you go. So that's it. Angular velocity of u on the surface of the Earth. Excellent. This is how I would do it. I would say that angular velocity, omega, is equal to, and I think I wrote these as full derivatives on here. You can view that, just the delta. The change in theta with respect to the change in time. Okay. And I kind of took the extra step, like I said, and said d theta dt equals, as we know from our notation, theta dot. So, one rotation of Earth is 2 pi radians. And again, because we know from our idea of a circle, divide this up here. This 90 degrees here would be pi over 2. 180 degrees would be pi. Here, what would this be down here? 3/2 pi, right?
Right.
So 1.5 pi. And then this, of course, would be
2 pi.
2 pi. So if this is the planet, let's say you're right here, so you're happy on the Earth because you have a nice livable atmosphere and nice weather so you can survive on other species. And you know that Earth is rotating. And in one full rotation, you'll have gone 2 pi radians. That's why one rotation of Earth is 2 pi radians. And you should probably recall that from geometry or trig or whenever you learn that. So, let's, is that the second?
Mm-hmm.
So one day is equal to, and now we're just going to do our conversion factors here. So if we want to take one day into hours, we would say there are 24 hours in one day. Day here, of course, the end would cancel out. And in hours, then we would say there are 3,600 seconds per hour. And that's just combining the seconds and minutes. And if you do enough times, you know that 60 times 60 is 3,600. So if we do all that, we get a number of about 8.64 times, it's 10 to the 4 seconds, yes. So something like 86,400 seconds if you're around. Alright, so now if we're doing radians per second, we would say that our angular velocity is equal to 2 pi divided by this number. And here, of course, you want to make sure you're in radians and all that. And you should get 7.27, is that what I've got? 7.27 times 10 to the negative 5th radians per second. And of course on your test I would give you in the problem what units I wanted.
That was us.